Okay, today we will speak something about RF absorbers, which will be used for energy harvesting. This is new area. People have worked only on retina for energy harvesting, but today we want to describe how we can play with new field using RF absorber for energy harvesting. Basically, the metamaterial are nothing but a artificially created surface of specific patterns, maybe square, ring, and combination of square, ring, and other formats. These structures are being used to convert the permittivity and permeability characteristics into DNG. DNG is double negative. These are the materials not found in nature but are artificially developed or created. The basic principle of working of RF absorber is that incident EM wave available in atmosphere will be used to generate DC voltage. This DC voltage can be utilized for operating IoT devices of less voltage required. Basically, the smart city, smart buildings are the main application area for absorber in RF energy harvesting. Smart city concept is new concept where for these IoT devices to operate, there is no battery or no external power supply is required. Only inbuilt the power supply will be captured from ambient environment, and it will be used to drive self-sustainable IoT devices. How it is being done? Basically, we use artificially developed materials. These materials are nothing but metamaterials. So the incident wave, which is frequency specific, is being captured by the structure which is designed to resonate at particular frequency, maybe at 2.4 gigahertz or 5.8 gigahertz. Now there is a capacitive and inductance in this particular surface which is being created using the conducting materials such as copper, gold, silver, etc. Now in this particular pattern of a surface which has a certain specific value of inductance and certain specific value of capacitance will form a resonant circuit, and the resonant circuit will be based on the value of L, that is inductance, and the value of C, that is capacitance. As we already know that the resonant frequency is equal to 1 upon 2 pi root L and C. So the L and C values are to be chosen in that particular way, so that the resonant frequency of particular nature, maybe 2.4, 5.8 or any other higher frequency can be designed for. Now the incident wave which is already available in our environment, maybe our house where 2.4 gigahertz Wi-Fi Bluetooth is already operating, maybe we can harvest the radar frequency which is there in the nature, which has very high EM wave strength. We can capture that. Now the incident wave which is being captured by the SRR or CSRR or any particular surface will have capacitive and inductance. So this capacitive effect which caters for electromagnetic charges will be able to develop surface currents. These surface current gets inserted into dielectric material which we devise for a perfect match of this particular structure, and due to perfect match the dielectric surface offer very low loss, hence the surface current gets entered into dielectric material, and this dielectric material will now offer dielectric loss, and the surface which is specific to metamaterial surface will offer conducting loss. The combination of conducting loss and the dielectric loss will offer a absorption, and this absorption can this is known as RF absorption. This absorption can be converted into corresponding heat dissipation, and if we want to stop this heat dissipation, we can place the diode across capacitance, and then with reference to ground plane and the diode positive, we can get these AC voltage developed across the surface, and further using rectifier circuit we can convert this AC voltage into corresponding DC, and where these DC voltage can be applied to the IoT which operate at very low voltage. Now basically there is a requirement of a perfect match in the total structure of the absorber design so far. The free space impedance is 377 ohm. So with the help of RF circuit matching, we generally operate at quarter wave transmission line, and that is lambda by 4. So overall structure is matched to 377 ohm impedance. Hence the incident wave which is available in free space get entered into this structure which is perfectly matched, and hence there is a loop current being formed inside the structure of RF absorber. This loop current will create dissipation or dielectric loss and conduction loss. This is how we can use these RF absorbers which are designed to a particular frequency to operate in ambient environment for supplying self-sustainable devices or self-sustainable IoT devices. So there is a tremendous application for RF energy harvesting applications, maybe for medical use, maybe for remote villages to get the power supply without any transmission line or battery operated devices. So there is a huge amount of scope for RF absorbers. Now, because the Schottky diodes and pin diodes used offer loss, so there is a new technology coming up. CMOS rectifiers are being available in the market, and now current research is going on towards minimizing the loss offered by these Schottky diodes or pin diode, and we are converting the Schottky diode and pin diode circuits from CMOS rectifiers. Hence, the present and the future research will be towards CMOS rectifier embedded with the absorber. That's all for the today's lecture. Thank you very much.